Alright guys, this is the second video of the day. This is probably the hardest problem of all of the problem sets because you kind of wrap your mind around what does it mean for acceleration. Alright, so we've got Jean dangling a thin piece of string from an airplane while in an airplane, and she notices that the string makes a 25-degree angle with respect to the vertical. So what does that mean? Here we've got a string here, and here's the vertical, and she's got a 25-degree angle. And she's got to figure out what's going on. All right. She is kind of interested in trying to understand what the acceleration of the plane is. And so she draws a free body diagram, and what does she get? Where there's the tension pulling up on the string because it's being attached to her watch. And then she knows the string has a mass, so it has a weight pulling down. And that's her free body diagram. And if she looks at the tension, well, interestingly enough, unlike our normal problems, the angle is here, right? So that's 25 degrees. So if you're looking at the y component of the tension, tension in the y direction is equal to tension, something we don't know what it is. We have no idea what that tension is, but we know that it's the cosine of 25 degrees. This y component is actually adjacent to the angle, and the tension in the x direction is equal to the tension, still something we don't know, times the sine of 25 degrees. And so we'd like to figure out the acceleration of the plane. And the only reason that this is pulling back like this is the string has inertia, and it really wanted to keep on doing what it was already doing. So it's resisting the acceleration in the x direction. All right, so now that we've done our free body diagram, let's think about the forces. So the forces in the y direction are equal to mass times acceleration in the y direction, and that's equal to 0. We don't see any change in the y direction of our object. And so if we put in the tensions in the y direction, well, we're going to call this the positive direction. Okay, we'll have our coordinate system be positive in this direction, and that's uniform motion. And in the x direction, that's the accelerated motion, and that'll be positive for uniform accelerated motion. So that's our coordinate system. So the forces in the y direction, well, we certainly have tension pulling up, so that's tension in the y direction, and we're going to subtract the weight in the y direction, and that's equal to 0, okay? Because we're accelerating for takeoff, and there isn't really any change in the y direction. And so that means tension in the y is equal to mass times gravity, and tension in the y is tension cosine 25, which equals mg. And so let's just rearrange for tension, because as we know, we'd like to get rid of it. So tension equals the weight divided by the cosine of 25. And that's the the y direction. That's all we can do in the y direction. So let's think about the x direction. In the x direction, the force of the x direction is equal to mass times acceleration in the x direction. And in the x direction, absolutely there's an acceleration. The airplane's going to take off. Okay, so our forces, well, in the x direction, we only have one force, and that's the tension in the x direction. So tension in the x direction, sine of 25, is equal to mass times acceleration in the x direction. And we want to, sorry, not in the x direction, but tension alone. And so we'd like to rearrange. Remember, the only force is tension in the x direction. So let's rearrange for tension so we can derive a formula that doesn't have tension in it. So we get tension equals mass times acceleration in the x direction divided by sine 25. Well, that's convenient. We have two formulas that are equal to tension, and we can set them equal to one another, and that gets tension out of the equation. So we get mass times acceleration in the x direction divided by sine 25 is equal to mg cosine 25. All right, well, as usual, mass doesn't matter. So the acceleration in the x direction is equal to g times sine 25 divided by cosine 25. And with a little bit of algebra, I believe we come out to, let's see, what do we got? I think, grab a calculator.